Hi, welcome to our pre-calculus. The topic today is multiple representations of polar coordinates. This is an issue that is particular to polar coordinates. A point can have multiple representation. For example, if I pick up a point on this circle here and ask what is the polar coordinate of this point, many answers can be given. For example, you can say, well, what was the polar coordinate? I start on the x-axis and turn until I arrive at a certain direction, and on that new axis I choose my point at a certain distance from the origin. So if I have traveled through this angle, perhaps this point has the representation r and theta. Well, is there another representation? Well, yes, I could continue and come back to the same point on the circle, but now I have gone through a much bigger angle, which is r and theta plus 2 pi. Well, I can repeat this scheme again, so I can go around the circle, come back, and now I have gone through r and theta plus 4 pi. I can go in the other direction as well. Sorry. So imagine that I go in this direction, come back. So now I have gone through I've gone through the angle theta minus 2 pi. So now I am at r and theta minus 2 pi. So the net angle that takes me from this point to this is theta minus 2 pi. You notice that these things differ, the angles differ by 2 pi. So I can add 2 pi or I can subtract 2 pi, and all of them brings me to the same point on the circle. So whatever representation I have, I can add multiples of 2 pi to it, and they all point to the same location. Now it becomes even more interesting than that. That is, let me erase these. I can travel by bringing the axis to this location, and then, so once the axis is here, let me erase the other one so it doesn't interfere with our picture here. Okay, so I can come here and then go to a negative r and arrive at this location. So I can go to negative r, and now what is this angle? This was, remember originally it was theta. So this is going to be pi minus theta. And since we are going in the negative direction, I have to write it as theta minus pi. Now I can go around this circle and then again come back to this location, or I can go in the opposite direction. So if I go in the negative direction, I'll be at the point r and theta, minus r, and theta minus pi, minus 3 pi. If I go around the circle one more time, I'll be at minus r and theta minus 5 pi. I can add 2 pi's and go to the other direction. That is, I can end up at minus r and theta plus pi, and then so on. minus r and theta plus 3 pi. So if you compare the two lists, we have two lists here, one associated to radius distance r and the other one to minus r. Let's say the original angle was theta. And this list, I can make it by adding and subtracting multiples of 2 pi from it. I'm sorry, I'll make a correction here. I can add and subtract multiples of 2 pi. The other list associated with minus r, all of their angles you can obtain by subtracting a pi from this one. So instead of 4 pi you have 3 pi, instead of 2 pi you have 1 pi, instead of 0 you have minus pi, minus 2 pi, no, minus 2 pi, minus 4, minus 3 pi, minus 5 pi, and so on. So within each list you go up or down by adding 2 pi's. Within the other list, same way, you can add and subtract 2 pi's. If you want to compare the angles, you can say that the one at the bottom list are pi less than the corresponding one that you had over there. So multiple representation that we are referring to is this two lists, and each of them made out of infinitely many instances. Okay, so what we are after here is to find out all the representations that fit in a certain window. So all of these problems ask you, well, this is an infinite list. Perhaps we don't want to have all of them, but we want to have a few. And the few that we are choosing are the ones that are going to be in certain range of values. So here the book is choosing from minus 2 pi to 2 pi. This is just arbitrary choice that we are making here. So let's go ahead and see what we can do. So we have our given location is 4 and 5 pi third. Okay, now I can choose to go another 2 pi on this thing. So 4 and it was 5 pi third. I add the 2 pi to it, and then I can add more, 4 and 5 pi third, and now I can add 4 pi to it. I can make a list, but they're not going to be required from me, because once I pass 2 pi, we don't want to list them anymore. We have already passed 2 pi here. We've already passed them, so we can drop these things from the list, and once it drops in that direction, all the subsequent ones are going to drop as well. You can add 2 pi, you can also subtract 2 pi. So 4 and now this 5 pi third minus 2 pi. What is that going to be? So I go ahead and subtract them, and so 5 pi minus 6 pi becomes minus pi third. Minus pi third hasn't hit my limit yet, so this is an acceptable number for me. What if I go another negative 2 pi? So r is still 4, and now I have whatever I was at, which was minus pi third. I subtract another 2 pi from it. Well, obviously now I am falling below minus 2 pi. This is minus 2 pi and I'm subtracting an extra. So this is going to fall out of consideration, and that means all the prior ones also going to fall out of consideration. So the only two that survives are filter. Here's our filters. Only choose the numbers between minus 2 pi and 2 pi. The only two that survive that process is 5 pi third and minus pi third. How about on the other spectrum? All the other ones, the radial distance is minus 4, and what we said is a simple way of handling these things is to subtract the pi from what you had. If you wish, if I subtract the pi from this, I have 5 pi third, subtract the pi from this thing, so it becomes 2 pi third. Is that right? So there's going to be 2 pi third. Okay, now next I can subtract from here. I can add to this one. I can add a 2 pi here, so minus 4, and whatever this thing is 2 pi third, and I can add 2 pi to that. Well, this is positive. Obviously, if I'm adding something to it, that's going to already exceed the top of my filter, so that's going to be out, and similarly, whatever comes after that is going to be out. Now I can go leftward. Leftward, I'm going to subtract minus 2 pi, or if you wish, I can subtract the pi from this one. Either way. So you come from here to here, you subtract the pi, or you go horizontally, you add or subtract 2 pi. So here I'm going to have minus 4 pi, and this is going to be 2 pi third minus 2 pi, which when I subtract it, it becomes minus 6 plus 2 is minus 4 pi third. So again, I went to the left by subtracting 2 pi, or you can come down this way and subtract just the pi. So subtracting a pi, I'll end up at minus 4 pi third. I subtract another 2 pi, so now I'm going to be 4, and this is minus 4 pi third, and then minus 2 pi. This is already negative, so I subtract that, I fall below the bottom of the filter, so that's going to be out as well. What survived this process? These two and these two, we always have 4 of these left, 4 and minus pi third. This is one representation, and 4 and 5 pi third that was given to us, and then minus 4 and 2 pi third from the other category, and minus 4 and minus 4 pi third is the final of these. So I have 4 options, and I enter them, and then I'm all set. Here's another example. Suppose a point has polar coordinate 2 and minus pi. So I have 2 and minus pi. What are all the ones that all the other representations of this? So we add 2 pi to this, so these are all 2s. So I add 2 pi to this, it becomes pi, so that's fine. I add another 2 pi to this thing, so it becomes 3 pi. Okay, from here to here we are adding, so we are adding 2 pi, we are adding 2 pi. Well, we exceeded the upper bound, so that's out. I can go the other direction. If I want to go leftward, I subtract 2 pi. So this is minus pi, subtract 2 pi becomes minus 3 pi. Okay, so I want to go this way, I subtract 2 pi. Well, that one exceeded that, so that is out. Now, I can go to the other branch, the other pile. All of these new ones are going to be radius minus 2. I subtract a pi from this, I get 0. Let me draw a picture so that it's clear as to what we are talking about. So here's a circle. What does 2 and pi mean? 2 and pi means start from, say, here and go angle of pi, and on that go to location 2. Okay, so if we come to this direction and go as far as 2, we have arrived at our final destination. Well, the other option that I have is to keep my original direction, but then go to negative 2 on that axis, and that's what this one is saying. Okay, negative 2 on the ordinary x-axis is same as location 2 on the axis pi. Okay, now I can add 2 pi to this thing, so it becomes minus 2 and 2 pi. So the other option I had was to subtract pi from that one. Minus pi brings me to 2 pi. If I go to the left of this thing, I will have minus 2 and minus 2 pi. And then left again, I will have minus 2 and minus 4 pi. In this case, we have 5 answers allowed to us because these endpoints, both of them are acceptable. It's typically one of them is excluded, but now here both of them are acceptable. So the answers that are going to be listed for us are these. Okay, so we chose them so that our angle neither exceeds 2 pi nor falls below minus 2 pi, and these are the 5 choices that we have. One more example that should bring it home. So here I have minus 6 and 3 pi over 2. Okay, we add 2 pi to this, so I'll have minus 6, and this is 7 pi over 2. Okay, so I added 2 pi. That is, obviously we already exceeded 2 pi, so this is out, and all the ones come after that will be out as well. If I subtract 2 pi from this thing, I'll be at point minus 6 and then minus pi over 2. That is fine because I have not fallen below minus 2 pi, but if I continue one more round, minus 2 pi, so this is negative itself. I subtract another 2 pi from it, definitely falls below this, so that one and all the ones after that, they are all out of the consideration. Now going to the other list, the sign of R is going to flip, so this is going to become 6. Okay, so we always flip the sign of R. So just as before, we can subtract the pi, and then this becomes pi over 2. Now you can add 2 pi to this thing, 6 and pi over 2, and then you add 2 pi to that. Already exceeded 2 pi because positive and you're adding 2 pi, so this will be out, and all the subsequent ones are out too. Going the other direction, we subtract 2 pi, so it becomes minus 6 and pi over 2 minus 2 pi, so that becomes minus 3 pi over 2. That's acceptable, but if you go one more round, minus 6 and this is minus 3 pi to minus 2 pi again, that will be outside of our filter and it's going to be excluded. So what is left at the end is minus 6 and minus pi over 2, minus 6 and 3 pi over 2, minus 6 and minus, this was plus 6, sorry. Correction, these are all plus 6s. Plus 6 and minus 3 pi over 2, and plus 6 and pi over 2. So typical situation, we have 4 possible representations of the same point with the angle between these two. Okay, so that is one of the prices we pay for going after polar coordinates. The situation is going to get a bit more confusing when you go to calculus, where verification of solutions for your equations is going to become a bit more complicated. But this is doable right now. We have 2 sets, one with R, one with minus R. Within each set you go up or down by adding or subtracting 2 pi. You go from one set to the other set by subtracting a pi. So this is that subtraction. Okay, until next time, good luck and God bless.